Hey grade 12s, today we're going to talk about permutations with repetitions. And in order to do that, we're going to talk about a couple different words here. We're going to start off by looking at the letters in the word pot. Now, pot, of course, has three letters, P, O, T. And we want to see how many different arrangements of those letters we can have. And I'm picking a three-letter word because it's fairly straightforward. So, of course, we have pot, and then if we stay with P being the first letter and just switching the next two, we have PTO. If we put O as the first letter, we have OTP or opt. And if T is our first letter, we have top or TPO. So as a total, there are 6 different arrangements of the letters in the word pot. Now, what about the arrangements of the letters in the word pop? Now, pop, of course, is different because there's a P, there's an O, and then there's a second P. Now, why is that second P important? Well, let's look at a couple things. Let's look at this one where it's pop, or let's look at this one where it's pop. Now, these are different words because the first one that I highlighted, the first P is leading off, and the second one I highlighted had the second P leading off. But even though they are different in terms of which letters in the original word are beginning and at the end, they don't look any different to you or I. So those two are identical. And as a matter of fact, OPP, this OPP, is identical to that OPP, and PPO is identical to this PPO. So where we saw in the last situation, if we had 3 letters, we got 6 different permutations. Here we see that there's clearly only 3. So there's only 3 different distinguishable permutations. And that's because of the repeated P, because there's 2 different P's. Okay? So that leads us to today's topic, which is permutations with identical objects. And here we go. The number of permutations of a set of n objects containing A identical objects of one kind, B identical objects of a second kind, C identical objects of a third kind, and so on is n factorial over A factorial, B factorial, C factorial, etc. So to see how this works, let's go ahead and try this example. How many permutations are there for the word Mississauga? So first of all, let's count the number of letters in the word Mississauga. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 factorial. And then what we want to see is how many letters have a repetition. Does M repeat? No. Does I repeat? Yes, twice. Does S repeat? Yes, 4 times. And does A repeat? Yes, twice. So we have 2 I's, 4 S's, and 2 A's. So this is going to be 11 factorial over 2 factorial, 4 factorial, 2 factorial. This is not going to be a treat to put into your calculator. You're probably going to have to end up doing this manually. So 11 factorial is 39,916,800. 2 factorial is 2, 2 factorial is 2, so that's 4. 4 times 24 is 96. So if we divide that by 96, we get 415,800. So that's how many ways we can arrange the letters in the word Mississauga. Okay? All right. Another example, a store has 3 boxes of Oreos, 5 boxes of Dad's oatmeal chocolate chip cookies, and 4 boxes of PC Decadent chocolate chip cookies. In how many ways can a store place the boxes beside one another on a grocery shelf? So we have 3 identical boxes of Oreos. We have 5 identical boxes of Dad's oatmeal chocolate chip cookies, very underrated, and 4 boxes of PC Decadent chocolate chip cookies. So how many boxes of cookies are there altogether? Well, altogether, 3, 5, and 4 makes 12. So I'll switch to my pen here. And so it's going to be 12 factorial. And there's 3 boxes of Oreos, 5 boxes of oatmeal chocolate chip, and 4 boxes of PC Decadent. So it's going to be, we're going to figure out what 12 factorial is. And so 12 factorial is a really big number, 479,001,600, all divided by 17,280 will be the denominator. And when we do the division, we get 27,720 ways of arranging the boxes of cookies. And that's all there is to it. So working with permutations that have repetition is fairly straightforward. It kind of builds on the idea of permutations that we learned the last lesson and also tells us how to treat situations where there are identical objects. Try the practice questions, and if you need any help or want any kind of clarification, make sure to ask.